We are going to look at plants that are hopefully growing and see what you decide you would like to do for an experiment on them. It is completely up to you. And last but not least, we are going to talk about animal tracks and how animals are tracked. We have a busy, busy day today. The first thing I would like to start off with is by sharing your projects about migration. Do I have any volunteers to go first? Go ahead and raise your hand if you would like to go first. No volunteers? Okay, then whoever is on top, which I do not remember who it is going first. All right. It looks like the first one is goose migration. Whose was this? Okay, I will go ahead and read Bayes to all of you. It is goose migration. It says geese come to the Netherlands to have a good winter. They are called winter guests. Geese come to the Netherlands because there is still grass and food in the winter. There is a lot of water in the Netherlands, and because we have soft winters, the water is almost all the time not frozen, and only a few days of snow. In March, they leave again to go breed by the polar circle. Very good, Bay. Bay wrote about goose migration. Next, we have Bella. Your zebra is next. Would you like to go ahead and share with us? Sure thing. So Bella wrote about zebras. Zebras migrate in search of better grazing pastures and water sources. Thousands of zebras from when they migrate. Form columns when they migrate. They begin their migration when the dry season occurs, and they herd from the south to the north. Then they trek back north around November when there is more water. Very good, Bella. Thank you very much. MacArthur is not on yet, so we're going to put his on hold. Maybe he will join us a few minutes late. And here we have Arsad did bats. Would you like to go ahead and share with us, Arsad?
Bat migration in Kasanka. Bat migration is the largest mammal migration in Africa. They migrate to Kasanka because there are a lot of foods. They fly from Congo about 1,000 kilometers from Kasanka. They usually come to Kasanka in October, and they will stay for 2 months until there is no more fruits to eat.
Very good. Thank you very much. Great job. Oh, Xana, do you have a question?
Oh, I lost my paper, but I just found it.
Not a problem. I have yours up here as well. Yours was a picture, though, so it's down on the whiteboard. So if you guys can click over to the whiteboard, we are going to look at Xana's paper. Let me just get it situated and turned the correct way. Give me 1 second. For some reason, it's not letting me turn it, Xana. Do you have a copy there that you can read? So we don't have to read sideways here?
Yeah, I have my paper right here.
Awesome. Go ahead. Xana did the Florida manatee.
The Florida manatee is an aquatic relative of the elephant. They are grayish-brown in color and average 9 to 12 feet in length and 8 to 1,200 pounds. They swim 3 to 20 miles per hour. They eat grass and plants. They only predators are humans. In the summer, they have been seen as far west as they have been seen as far west as Louisiana and as far north as Massachusetts. In the winter, manatees migrate to the warm for the water. Many manatees gather in the Crystal or Homosassa rivers where the water temperature is constant 72 degrees Fahrenheit year round.
Awesome. Great job. Thank you very much, Xana. Okay, so you guys, as I said, did a fantastic job on that. Now, I would like to share my humpback whale migration with you. So mine is up on the PowerPoint screen. And this was supposed to be the end of last class, but we ran out of time. So go ahead and make your PowerPoint screen larger. And here we have why humpback whales migrate from Alaska to Hawaii. A whale of a tail. So what is migration? We talked about this last week. So as a review, migration is the seasonal movement of a population of animals from one area to the other. You guys talked about zebras and bats and manatees and geese. Another example is whales. Okay, here we go. Humpback whales are migratory animals. They travel up to 3,000 miles from their feeding grounds in the cold winter waters of the polar region, all the way to their breeding grounds, which are in the warmer waters of the tropical regions. So here's a picture where they might start. So they may start up in Alaska, and some of the whales go down to Hawaii. Some of the whales go towards Mexico, and some of the whales go towards Japan. When do humpback whales migrate? And here's a couple of pictures. The humpback whales follow a general seasonal pattern of migration. They leave Alaska when it gets colder in the wintertime, and that is when they journey south. So during the summer season in the northern Pacific Ocean, humpbacks can be found in their feeding grounds in the waters of British Columbia, Alaska, and eastern Russia. Basically, on this map, the parts that are enclosed in the dotted lines tend to be where the whales will spend their summers. Now, as the water drops in temperature, getting ahead of myself here. Due to the mild weather during the summer season, these polar areas produce an abundance of food, including krill, plankton, and small fish for the whales to feed on. Krill are small, almost shrimp-like animals. Here's a picture of a humpback whale feeding. He's straining water out of his mouth to trap the krill in his baleen. And you can see behind him, there's a little iceberg. So even though it is very cold out, it is still considered their summer season. Okay, we're going to flip through these because we've already done this. So then what happens is here comes the cold. The summer season is ending. And when the winter months set in, the waters of the polar regions become too cold and harsh, causing the humpback's food source to become scarce. Humpbacks then travel to the warm, protected waters of the tropics during these harsh winter months. And there you can see the white sandy beaches of Hawaii. The tropical waters tend to have much less food available to the whales. So they do most of their feeding up in the cold Arctic during the summer, and then when it gets too cold there and they travel south, they aren't traveling to eat, they are traveling to begin the breeding process. So their migration is mainly for breeding. There are humpback breeding grounds in Hawaii, Central America, Mexico, or Asia. Most of the whales, if you look on this picture, go down towards the Hawaiian breeding areas. However, you can see where the other ones go using the lighter yellow or following the red or the green or the light blue arrows. Sometimes a whale will go between the 2 or 3 breeding areas, and those are the black arrows on the bottom. So it is estimated that as many as 10,000 humpback whales travel from Alaska to visit the Hawaiian Islands every winter. This migration starts in November and lasts through about May. All right, so that was my migration story to share with each of you. So hopefully you found that a little bit interesting. But one question that always comes up when we talk about migration is, that's great that the whales move around, or that the bats move around, or the zebras, but how do scientists know that the animals do this? Anyone have any guesses? How do the scientists know? Just go ahead and raise your hand. How do they know the animals are moving? Jackson, go ahead. Your microphone wasn't working, Jackson. Go ahead and check that it's not muted, and we're going to let Xana go next. Xana, go ahead. How do scientists know that the animals are moving?
They track them.
Okay, they track them. Okay, Arshad, what do you think?
They do observation.
Okay, they make observations. Very good. Anyone have a guess as to either how they could track the animals or how they can make observations that the animals are moving? There's lots of different ways that they do both of those things. Xana, go ahead.
They can put cameras on them.
Very good. One of the ways they do it is they put cameras, or can put cameras on the animals, or they can put cameras at strategic spots to see if the animals come by. So that's one way, using cameras. Bella went ahead and put in the text chat that they can put tracking collars on them. Very good. They can put collars like you might have a dog or a cat collar around their neck. They can put tags or collars that transmit either radio signals or satellite signals on the legs of birds. And another interesting fact is one way that scientists track turtles is by putting the satellite tags right on their backs. And every time their back breaks through the water for sea turtles, it sends a message to a satellite so scientists can determine where the animal is. And for land turtles, scientists sometimes put a radio transmitter right on the back of their shell, and then they take a little antenna, like from an old TV, and they go out and they kind of listen to the beeps, and as the beeps get louder, they know they're getting closer to the animal. So we have satellite tracking, cameras, putting tracking collars on the animals, radio transmitters, just watching and observing. And those are all great ways that scientists track animals. There's one other way I'm thinking of that is something you can do in your yard. Can anyone think of a way to track that you can do in your yard? You don't need anything fancy to do it. You can observe them in your yard, but what else could you do besides looking at the actual animal? Has anyone ever seen footprints of animals in their yard? Go ahead and raise your hand if you have. Only Xana has ever seen footprints? Xana and Bella? Has anyone else ever seen footprints in their yard? Or maybe not in your yard, maybe down by a river? All right, well, I'm going to put a few pictures up for those of you who haven't seen animal tracks. And another way that scientists can go ahead and determine when an animal has been around is by looking at their footprints. Here are some animal footprints. And right now it's not important what animal they are. We're going to talk about that in a couple of minutes. But what is important is that animals can leave behind traces of themselves even if they don't leave anything. For example, the top picture that I just put up here on the right-hand side is a picture of an animal footprint in snow. That actually is a raccoon footprint, but let's just pretend that it snows in your yard. And I know some of you live places where it can't snow, but pretend we all live somewhere where it snows. And now let's say your mom has a bird feeder up in the front yard, and something took that bird feeder and moved it all the way to the other side of the yard during the night. Well, you would not have been able to observe the animal that did that, but you may be able to find its footprints in the snow. And then if you had a printout of different animal footprints in your area, you would be able to determine what animal stole that bird feeder. This is also great when you are trying to figure out what animals live by you. Now, obviously it doesn't snow everywhere, but it can, or animals can, leave behind footprints in snow. They can leave behind footprints in a sandbox. They can leave behind footprints on a muddy path. Or sometimes, if the animal is big enough, they can even leave footprints in your yard. So now that I've sort of described a track, go ahead and leave me or give me a smile face if now that I've described it you think you may have seen animal tracks either in your yard or around your house before. One thinks they've seen animal tracks in their yard before? All right, well, we're going to take a look at some tracks that you may find. And I'm going to need some volunteers to read, or can read if you guys are interested. So here we have animal tracks. The first animal I put up here is a black bear. Okay, there's a picture of a black bear up at the top, and then there are pictures of their front and back paws on the bottom. Would anyone like to read this? Xana, your hand was up first, so go right ahead.
Black bears are the smallest American bears and the most common. They are the only bears found in the wild in California. Although the grizzly bear is a state mammal, it has been extinct in California since 1922. Black bears are usually nocturnal, but can be active during the day. Bears are strong, agile, and quick. They swim and climb trees well. A bear can run 30 miles per hour in short bursts.
Good job. Thank you, Xana. So these animals would be difficult for you to observe in your yard because they are usually nocturnal, but you certainly could find their footprints around you or around your house. The next animal is a coyote. Would anyone besides Xana like to read the slide? Arsad, go right ahead.
Coyotes are very intelligent animals that have been able to adapt to many different environments. Some live in major cities such as Los Angeles, feeding off human garbage and hunting mice and rats. In fact, the city of Los Angeles is home to about 3,000 coyotes who roam the streets at night. They have adapted so well to the urban environment that few people even know the coyotes are there. tracks average 2.5 inches long. The hind print is smaller than the front one. The inner two toes are smaller than the outer two. Coyotes have great stamina. They are good runners and swimmers. They can eat wide variety of food such as small mammals, eggs, fruit, berries, nuts, rodent, fish, carrion, insect, grain, vegetation, and even human garbage.
Very good. Thank you very much. So now this certainly is not a track you'd want to find around your house either. However, there are coyotes around my house and around a lot of areas. They are not uncommon, but if you found them, you would know that you need to be careful. And a dog's track looks similar to the coyote track that's up here. Next, I have a gray squirrel, something that is pretty common around most of your homes. Would anyone like to read about the gray squirrel? Xana, go ahead.
Gray squirrel on the side of Douglas fir tree. The hind feet can turn backward, allowing the animal to descend a tree head first. Gray squirrels are common in many regions. They have large bushy tails and gray fur. Since they love to eat acorns, they are found commonly in areas where oaks grow. They also eat nuts, berries, fungi, larvae, vegetarian, and insects. The call is a whole spark. They make the bulky nests high up in trees from leaves, sticks, and bark. In winter, they find shelter in the tree halls. Gray squirrels do not hibernate. They are active year-round. Usually 4 to 6 young are born per litter. They show 4-foot clear tracks may sometimes be found along rivers' edges where the animals come down to drink.
Awesome. Thank you very much, Xana. Now go ahead and give me a smile face if you guys have squirrels around your house. Only one? I would have thought almost all of you would have had gray squirrels around your house. All right, there we go. That's more what I was thinking. Gray squirrels are very common, and I have lots of gray squirrel tracks around my house. One interesting thing that you guys could do is if you have any sand, like in a sandbox, if you take some out and spread it on your driveway or just in a little box in your yard, like the lid for a computer box is a good thing, you can go ahead and you can see if any animals step in it overnight. All you have to do is just make the sand a little bit damp. Our next animal is the porcupine. He's sitting up there in the middle of the log. Jackson, why don't you read this one for us?
Porcupines are nocturnal vegetarians that eat the inner bark of trees, twigs, leaves, buds, and flowers. They move slowly and don't see well. They climb trees to escape predators. They do not shoot quills. The quills are loosely attached and attack the slot predators with their tails.
Very good. Thank you very much. And our last animal and track is a moose. Is there a volunteer who would like to read about the moose? Zana, go ahead.
Moose. Moose are the largest deer in North America. They are herbivores, preferring to eat willow and fur.
Very good. So there obviously any animal that walks on the ground will leave a track. Animals that fly, like a bird, will leave a track when he lands. This is just a selection of animals. It is really what I just said about the sand. If you set that up, you can go online and you can type in your state. And let's say I do Connecticut. So I type in Connecticut. I can type common Connecticut animal tracks. And the most common ones will come up. I can print it out, and then I can figure out what type of animals are in my yard. Now, I know from doing an activity similar to that in the past that I have lots of deer in my yard. I have lots of squirrels in my yard. I have gotten the tracks from some birds in my sand. You could also get tracks from a snake if a snake were to cross over your sand. Now, a snake track doesn't leave a footprint. If you look at your whiteboard, a snake track, and this isn't going to be a super good one, but a snake track sort of leaves a curved line. That could also be from a worm, if a worm were to go over your track. Now, the way you would know the difference is just based on how thick that track would be. Yeah, I thankfully do not have a lot of snakes in my yard, Jackson, because I do not like snakes. They and I do not get along. So now what we're going to do is talk about the other type of tracking. The tracking that we talked about with the satellites. And we're going to talk about tracking sea turtles. Go ahead and raise your hand if you have ever tracked the movement of an animal on a map. Raise your hand if you have ever used a map to track the movement of an animal. Okay, Jackson has. Very good. Well, we are going to practice doing this together. And I'm hoping that it will work well. But it's only going to work if everybody works together. So this is what we are going to do. We are going to predict how far a turtle will swim in 90 days based on the map that we make of just a couple of days. Okay, so that's sort of the purpose, is to predict how far our sea turtle swims in 90 days. Now, this particular sea turtle that we are tracking is tracked using a satellite tag. So that means every time the sea turtle's back goes out of the water, and let's pretend that my arm is the top of the water. If this pencil is my sea turtle, when he is under the water, we do not know where he is. But as he comes up to breathe and his back goes over the water, there's a little tag on the back that then sends a signal to a satellite up in space. That satellite up in space sends a signal to a computer, and we know exactly where this turtle is. Then he goes back down, and he might stay under the water for another 20, 30 minutes. But then when he comes up, when his back breaks the surface, it sends another signal to the same satellite. So we are going to track our turtle. And our turtle is called turtle number 10. So up on the whiteboard, I am going to put a map. So please do not make any marks up on the whiteboard until I tell you to. Okay, and let me pull the map, so give me 1 second. All right, so let's see if it came through. All right. Nope, I will be right back, guys. All right, now hopefully the map will be here. Awesome, and there it is. So we have the points on the left-hand side that say location point for turtle 10. And then we have on the right-hand side here our map. Now the first point I am going to put on here. We're going to work through this together, and hopefully everyone will be able to put a point on our map. I'm actually going to try to make our map a little bigger and the point a little smaller. Is anyone else seeing an error? All right, if no one else is seeing an error, then Arshad, I would go ahead and log out and log back in. That usually tends to solve the problem. So I am going to make my point in red. I am going to do point 1. Point 1 has a latitude, if I look over on my chart and I just put my laser pointer on it, of 18.302. Now it's going to be hard for us to do this exactly, so we are just going to do the best we can do. So it has a latitude of 18.3, we're going to say. So now I need to go over to my map, and here is a latitude of 15, and here is a latitude of 20. So I am going to say a latitude of 18 is going to be about where I just drew this line. That's going to be about 18. Now it's not exact. Nothing that we do today is going to be exact. How am I doing what, Jackson? How am I writing on here? I'm using the text feature. It doesn't seem to be cooperating right now. Oh, only I have a laser pointer. You don't have a laser pointer. Only me. So this is about 18 degrees. Now we need to find our longitude, which is 103.427. So I'm going to draw a longitude line of 103, and I'm going to do this one in green. So a longitude line of 103 is going to be about here. Now remember, these are just estimates. They're not exact. So for our first point, we need to plot 18.302 and 103.427. So I am going to choose my circle. I am going to make a red mark at about 18.3 and 103.47. And that is about my point. And then next to it, I am going to mark point 1. Now, this turtle does not move quickly. The turtle moves slow. I am going to give you each a point to plot. So I did point 1. Now, I am going to have our sad. You are going to do the day from March 11th with the A next to it. And Bay, you are going to do March 14th with the BA. And Bella, you are going to do March 26th with the BE. And Jackson, you are going to do the one with the JA on the bottom from May 7th. And Xana, you are going to do the one with the ZA from March 5th. So I would like you to try your best to make your mark on the map. Okay, I know that this is probably something you have not done before. And I know it is difficult with the mouse, but go ahead and see if you can make your points.
I don't know where you put my point. I mean, I don't get this.
Okay, what you guys are doing is you're trying to make your point. So Xana, your point, I put a ZA. Let me turn my laser pointer on. I put a ZA right here next to the point. So your point is 18.2, which is where I had this black line, right where my laser pointer is 18. And your longitude is 103.2. So yours is going to be very, very close to mine. And you're going to find your point right here. Maybe it would be easier. Let me try this. Instead of trying to find that point, let me give you each an easier point to start with. So, Xana, your point is 15 latitude and 100 longitude. Okay, so what you are going to do is find where 15 latitude, which is this line right here, and 100 longitude cross each other. And then you are going to make a point. Okay, so Bay, I'm going to make one for you. Bay, your point is 95 longitude and 10 latitude. Okay, and I wrote it up on the bottom for you. Okay, I see yours, Jackson. Thank you very much. All right, Xana, you have another question? Go ahead.
I found it, but I cannot write on it.
Oh, okay, that's fine. I'll go ahead and make yours then. Okay, so this is probably going to make it easier. So I'm going to get rid of that. I'm going to give you guys new points. Okay, Jackson, you found yours already. Xana has hers. Bay. Now, Bella, let me give you a new point. Your point is a latitude of 10 and a longitude of 100. And our SAD, your point is latitude of 15 and longitude of 95. All right, so what you guys are doing is you don't need to draw the lines. You can, but what you really need to do is make your point. Okay, so I just made a triangle at 90 degrees longitude and 10 degrees latitude. When you think you have made your point, Jackson, yours is correct from your old one. When you think you have made your point, either with a shape, a scribble, a letter, whatever you want, go ahead and put a check mark next to where I have your point written, or a little slash next to it. So then we can go ahead and look at your points. Okay, now this tracking is very important for scientists because they are following where this sea turtle or whatever animal they are tracking is going. Who would like to do another one? I don't know who wrote that. I can't tell who writes. Yes, I can put another one up there for you, Jackson. So once you are done, put a check mark next to your name. And then what a scientist would do is they would follow the turtle, in this case, to figure out where that turtle is going. Okay, so Xana can't write, so let me do hers. Xana is 15 degrees longitude and or latitude and 100 degrees longitude, so she is right there. She is the square. We'll give her a pink square. So Xana is set. And Bay, your point is 95 degrees longitude and 10. You put a check mark there. Good job. Here is Bay's point. Bella has a latitude of 10 and a longitude of 100. Her point is right there. Good job. Arsiad has a latitude of 15 and a longitude of 95. He is this black triangle. Good job. Jackson has a latitude of 10 and a longitude of 95 down here. Okay, so great job. Now what a scientist would do next is they would connect their dots. So we are going to connect, I am going to connect them with red. And we are just going to go from top to bottom. We are going to assume this is the order of dates. So Xana, yours is first. You have 15 latitude and 100 longitude going to Bay, which is 95 longitude and 10 latitude. So our sea turtle went like this. Then our sea turtle went to Bella, who is 10 degrees latitude and 100 degrees longitude. So then he went to here. Then he went to Arsad, which is 95 degrees longitude and 15, he went up here. And then he went down to Jackson, who is 10 degrees latitude and 95 degrees longitude. And that was the track of our sea turtle. Now, did this sea turtle move in a straight line? What do you think? Yes, no, maybe? Did the sea turtle move in a straight line? Or did he zigzag through our ocean? We have a maybe, and then we have a zigzag. The sea turtle definitely zigzagged through our ocean. If it had moved in a straight line, it would look something similar to the blue line up here in the Gulf of Mexico. And that would have connected our points. But sea turtles and other animals grading do not necessarily move in a straight line. They are much more likely to move like our red line down here than in a straight line up on the top. Great job. It certainly is difficult to map how animals move, but it certainly is something that scientists need to do all the time and need to get good at. Otherwise, they do not know how animals move. So now we know how animals move, but why do we care? Why do scientists care why this sea turtle moves? Anyone have a guess? Why do you think a scientist is interested in figuring out why a sea turtle moves or why a butterfly flies? Why is it important? Jackson, go ahead. Make sure you click the talk button, Jackson. Why do you think it's important that scientists know why a turtle or an animal moves? Okay, so people can learn more about them. Very good. It might be important to learn if they are being hunted on one of their paths so that they can help protect them. With the whales, we learned they move in order to feed. So that's important if they're having their young or their babies in the southern oceans. That's important for scientists to know so that we can protect them. It's also important for scientists to know where animals are so that if there is a problem with them, maybe there's only a few turtles left so that scientists would like to try and protect them, so they can go ahead and do that. So tracking an animal is important for those reasons, and it just helps us learn more about those animals. Maybe the food sources that they eat or what type of habitat they like to live in. Now your homework tonight is to go ahead and think about animal tracks that you might find. And we are going to, there are two options. The first option is for you to make up a story. A completely fictional creativity story that you come up with about a picture that I put up there of some different animal tracks. Now it's not important what the animal tracks are from. Just use the picture to guide you. The second option you have is to write a nonfiction story or paragraph, not really a story, paragraph about a time that you found some animal tracks and either describing them to me, what you think happened there, or what animals they were from. So you have the choice to choose a fiction story paragraph that you are writing or a nonfiction. If you would like to write more than a paragraph, Jackson, you certainly can. That would be great. We are going to share these at the beginning of class next week. We only have 2 more classes. We have class next week, then we have a week off, and our last class is going to be on Tuesday, May 12th. And I'm going to send an email reminder about that week off. I had talked about it briefly at the beginning of the year. I'm actually going to be on vacation that week, so we will not be able to have class. So we are going to do our makeup the following week. So if you guys have any questions, feel free to give me a call. Have a great time being creative with your writing if you choose the creative lesson. And have a great time looking up some facts if you would like to do the nonfiction choice. I hope you guys have a great week, and I will see you again next Tuesday. Have fun! Bye-bye.